In 8086, it is divided into segments, logical segment. Don't think that segment means physical segment. Say, for example, in our house, we are getting in, there are different physical segments are there. Kitchen will be there, storeroom will be there, living room will be there, bedroom will be there. So there are physically divided, right? That and are physical segments. Whereas if you take this data segment, code segment inside 8086, or logical segment, logically they are divided. Okay, there is no exact cutting of the memory space. Okay, depends upon the need, it will get divided. Okay, so don't think that one particular area is assigned for data segment and another particular part of memory is divided for code segment. No, all these segments are logical, illusion only, on imagination side only, logical segment. Okay, now first we will start with data segment. So now what I said in data segment, the data segment is used to store data. Okay, in code segment, what is the use of code segment? The code segment is used to write the code. Okay, so in our program, in this program, we are using only two segment, data segment and code segment. If I'm using strings and all, what segment I should add? Extra segment. If I'm using a string as my input data, then I should include extra segment. And similarly, if in my program I am using push, pop and all, then I should insert what segment? Stack segment. So depends upon my need, I can insert the segments. Okay. Now, first what I am doing. So here in data segment, actually what this program will do was very simple. It is going to calculate result equal to, okay, result equal to N1 plus N2. So what I'm going to do in this program, very simple thing, result equal to N1 plus N2. Okay, so in C language, you want to do this coding. What you will do first in C language? So C, you are all familiar with. So with that knowledge, I'll explain this. Write the algorithm. I mean steps. What are the things to be followed? If you know the steps, very easily you can write the coding. Now, okay, in C language, if I'm giving result equal to N1 plus N2. So what is the first thing you will be doing? First, you will be declaring N1, N2 and result. Am I right? Next thing, what you will do, you will assign values for N1 and N2. Am I right? After that, after assigning, third thing what we will be doing, we will be performing the addition operation. Like result equal to N1 and N2. Okay. So, and finally, after adding, what you will do, you will print the result on the screen. Am I right? So, this is how you will do in C language. So, first you will declare the variables, then you will define the, defining means, declaring means allocating the memory location, defining the variables means you are assigning values to the variables. After that, you will perform the operation and finally you will be printing the result on the screen. So these are the four steps you will be doing with C language. The same kind of things only we are going to do here also. What we are going to do? See here, for declaration and all the data will be dealt only inside the data segment. So that only I am going to do now. So here, so what you have to do? You have to start with data, okay, and followed by, you should mention again, segment is a assembler directive. What is assembler directive? You are telling the assembler that this is not any operation. You are telling the assembler that I am going to create a data segment. Are you clear? So if I'm giving data segment means you are telling the assembler that I am going to create a segment. The name of the segment is data. Okay. And then how to end the data segment? Again, if you see, same data, whatever name you are giving, that name and end S. End command is also there, end S. See, end S means end of segment. Make a note, end S means if you have note or pen, or I mean note and pen, please make this Write this program on your notebook. What, line by line, whenever I'm explaining, line by line, you write it on your notebook. So here, data end S. S means end of segment. So this is the starting location of segment and this is the ending position of segment. So inside these two, like in C language, we are having no inside curly braces, you'll have some set of commands for a block. Similarly here, in between data segment and data enders, I have to type all the data, whatever I'm going to use. So here, what are the data I'm going to use? I'm going to use N1 and N2 and result. So you write N1, N2 and result. After that, I have to tell the data type. What kind of data type I'm going to use? Define byte. Byte means I'm going to use 8-bit data. And here also 8-bit data. And again, result is going to be also 8-bit. And here I am assigning N1 equal to 12. Okay. And here N2 is going to be 21. Okay. And then for result, I don't know the value. So what is the use of question mark? I said, if I don't know the value, then I can initialize it with question mark. So the result I don't know. That only I am going to calculate. Okay. So I have declared two variables and result I put question mark. Why? Because I don't know the values. Okay. Now I'll take next segment. Code segment. Again, if you see, code is the name for the segment. And I'm denoting its assembler directive. I'm telling it's a code segment. And I am terminating with code ends. Okay, so here this is the end of the segment. So inside this only I'm going to write my program. So how to write? Now I'm having one assume statement. Okay, what is this assume? So again, assume is a assembler directive. What is assembler directive? What is the definition for assembler directive? You are instructing the assembler to do something. Okay, this is not operation. Operation means addition, subtraction, mul, div, move, this and all opcodes. Whereas assume, segment, enders, this and all assembler directives. So this and all will not convert into any other thing. You are just instructing directly, it will instruct the assembler, you do this. That is assembler directive. Now, assume is the assembler directive. What you are telling that, what name I have given for code segment? Code. See, in this place, you can give your name also, it will work. So, only thing what you should do is, whatever name I have given for code segment, this is alias name, giving some other name. So, assume this code for CS. What is the CS? In register set, we have seen in 8086 architecture, code segment, CS. So, we are telling the assembler, the alias name for code segment is code, C-O-D-E. And again, see here, this place you should put a colon. See, everything matters. If you put semicolon, it gives you error. So be careful. Assume that whatever you want to assume, put a colon, not semicolon, put a colon and give any name. You can give any name to your code segment. Okay. And for next, you should put a comma. So this place, you please be careful. See, these are the places students will normally make mistake. That is why I'm repeating that. So put a comma there. And again, DS, data segment. So what name I have assigned to data segment? This name. Okay, here also you can give any other name. But for understanding purpose, please give data segment name as data. For code segment, give code. Okay, so this is about assume. We are telling the assembler that CS is going to be code in this program and DS is going to be data in this program. That's it, over. Now, after assume, the next step is start. Okay, so start colon. Okay, what is this start colon? Why I am giving start? You may have a doubt. Why don't we didn't give the start outside code segment like that and all? You may have a doubt. See what this start refers to. See here, start is like a main function in your program. In C language, in a single program, you can have more than one function. Maybe main function is must and then you can have add, sub, mul, like that. Different functions you can define it inside a single .c program. Okay, in that, whenever you are executing the program, from where it will start executing, you are having many functions in a single program. Like I'm having, for example, I'm having main function and then add function, sub function, everything inside a program. Okay, so normally if you execute this program, C program, from where it will start executing, automatically it will start, many functions are there also, it will start executing from main function only. Similarly, here in this program, I can have any number of code segments. Okay, in this program, I am having only one code segment, but I can have any number of code segment. Okay, each code segment will do some specific task. But in whichever code segment I am having start, then from there only it will start executing my program. Again, start is a assembler directive. Start is a assembler directive. What is the use of start? In I can have any number of code segment inside one single program, but where to start? To denote that, I will be using this assembler. So that is why the start is given here. That means the program will start executing from this place. So this is the starting place of my program. So start colon. Okay. After that, so now only we are going to start our program. Now the first statement is move AX comma. Okay, so the first statement is move AX comma data. Here what I am doing is I am getting the starting address. Say for example, I am having int A of 10. Okay, so in C language. Okay, and if I am telling simply A, in printf I am giving A. So what it will print? Only I am mentioning the name. So what it will print? It will print the starting address of the array. Okay, A means starting address of the array. Similarly, here I have stored some sequence of data. So the starting address is what? Data. Okay, so what here I am doing is, this data contains a starting address. Starting address of the data segment. Okay, so I am moving that into AX. Okay, now my accumulator, AX means what? Accumulator. My accumulator contains the starting address of what? Data. Say for example, this is my data segment. So I am pointing to this. Okay, so this is data. So data is pointing to this area. So in this area, what I am having? N1. Okay, say for example, the address may be some 1000. So inside this, what value I am having? 1, 2. So I am taking from this and writing. Okay, I am writing. Okay, now, so what here will happen? This 1000 location is there, no? This 1000 will be moved to AX. Okay. After that, what I am doing in move statement? I am moving this 1000. AX contains the starting address, no, 1000. This 1000 to DS. What is DS? DS is data segment register. Do you remember in architecture we have seen? So the DS register will contain the starting address of the data segment. So whatever memory location is allocated for this, I am assigning this number to DS. So hereafter, my data segment register will point to 1000. Are you clear? So for this, I am writing two statements. You may have a doubt. Why, madam? Why you are giving two statements? Instead, directly I can give like move ds comma data. You may have a doubt. Why don't we give it like this, ma'am? Directly move the address to data segment register. Why you are giving in two steps? Why? Because this format is wrong. While explaining about move instruction, what I said, you can't touch the segment registers, right? So we are not allowed to use the all the segment registers directly. But with the help of accumulator, I can access the data segment. I can't touch the DS and all, sorry, CS and all, code segment and all, I should not touch. I can only access the data segment register, that too only through accumulator. That is why first I am moving data, this address, data address to AX, and then I am moving this AX accumulator value to data segment register. Okay, after giving this, what will happen? My pointer, my offset will point to this particular address. Now it is pointing to N1. So here you can see. Okay, so now it is pointing this area, no? Now N1 value is moved to AL. Why? Because it is 8-bit number. AL or AH you can use. And then N2 value is moved to BL. Okay. And then here I am adding AL and BL. So what this means, add AL comma BL means what will happen? AL equal to, this is equivalent to AL equal to AL plus BL. So it will add AL and BL and the result will be stored back to AL. Okay. After that, I am having the result in AL. So this AL value will be moved to result. So here we declared no result. The value will be moved to result. That's it. And interrupt 21H is like in C language you are writing return 0, no? It will return the value to the OS. Okay, for normal termination, it will return the integer value 0 to the operating system. Like that, if you want, you include, otherwise you can omit this also. And then here you can see code segment ends. Okay. After that only, I should end the start. Why I am having end start after this? Why? Because in between this, I can have some more code segments. Okay. Some more code segment I can have. So finally only I can end the start. Okay. In between one single program, in between two curly braces, I can have any number of functions. Okay. So finally only I should terminate the start. That is why end start is coming outside of code segment. Okay. So now what's given here? First part is data segment. You declare all the variables in data segment and the program will comes in code segment. The first statement of code segment should be assume. We are telling that this code name is given to code segment register and name data is given to DS. After that you should put start colon. So this is similar to main function in C language. After that you are moving the starting address to AX. Okay. And then the AX value to data segment. So when I am giving this, the data segment register will point to the data segment area. Okay. After that only, after these two statements only, I can move N1 to, N1 is declared here, no? N1 to AL, then N2 to BL, and then I will be adding these two registers. And then what I am doing, the result I am moving to result variable. That's it.